All right, and welcome to another edition of Way Happy Studios Math the Fun Way. This is Mr. Meyer, and we are doing multiplying and dividing rational expressions. So let's talk about some rules when you see rational expressions, which just means fractions that got a bunch of x's in them. And so the thing that you want to worry about is that you want to factor the top, factor the bottom as much as you can. Hopefully, you can cancel out some of those things. And then once you've done all your factoring and your canceling, try to multiply all the tops together, multiply the bottoms together, and then just make sure that you've factored everything out. Make sure there's nothing left that could still be reduced. And so let's try example 1. This doesn't look too bad. I'm going to simplify this down as far as I can. Now notice I have x's in the top, I have x's in the bottom, so they should definitely reduce. And I also have a 10 over a 6. That one we know should reduce also. So let's see. Let's work kind of numbers first. I'm going to work with the 10 and the 6. I'm going to reduce that to 5/3. And then how are we going to reduce the x's? Well, there's a couple of ways. One math property says, hey, look, if you have division, you can subtract the exponents. So you would get x to the 4th. And since it's positive, you'd put it in the numerator. That is fabulous, right? There's my final answer. If another way would be if you're kind of more of a visual person, you would say like, oh, I know I have 8 x's on top, which hopefully you won't do this for very long just because it would be annoying, and 4 on the bottom. You could cancel 1, 2, 3, 4 and realize you're left with 4 x's on the top. So that's another way that you could get that final answer. But final answer, 5/3 x to the 4th, or if you want 5x to the 4th over 3, doesn't really matter. Those are the same thing. And you have just simplified an expression. All right, let's look at B. B may be a little goofier, right? B tells me that I have something over something, and so the best thing there to do is factor. So let's factor the top. So do you know anything that multiplies? So remember, you multiply the outside numbers, which is -2, and it's got to add up to the inside number, which is 1. What two things do you know that could multiply to -2 but could add up to 1? Ooh, I think it's 2 and -1. And so there's your factors. You have x plus 2 and you have x minus 1. All over, factor the bottom. Let's see, what two things do you know that multiply to -3 that add up to 2? Hey, I think that's 3 and -1. So that would be x plus 3 and x minus 1. Hey, lo and behold, notice what happened. The x minus 1's cancel, and you are left with x plus 2 over x plus 3 as your answer. Now, one thing I didn't pay attention to, and I need to because it's very important, is that tell me for which x values it is undefined. Now, there's about 3 things bad in math that I can think of. We never want negatives under square roots because that leads to imaginary stuff, and we usually can't graph that. So unless we're looking for imaginary answers, if we're looking for real answers, this is a bad thing. After the word log, you never want to have a negative number or a 0. Those are both bad after the word log, right? So you can't ever have that. So those are 2 things we worry about. And then the most important one, or the one that's going to be here, is that I never ever want zeros in the denominator of a fraction. That is also bad. These 3 properties are something you want to make sure you memorize and that you always pay attention to, that you never want negatives under radicals when you're talking domain and range or real values. You never want negatives or zeros after the word log, and you never want zeros in denominators, ever. And so look, right up here at this step, there was 2 numbers that were bad in this problem. X cannot equal -3 and x cannot equal 1. Now sure, we canceled that 1, but it was still there in the original problem, so 1 was trouble. Even though it canceled out later, it was still trouble, and so we always want to remember that. Probably also here in example A, I should have said x cannot equal 0 because I don't want a 0 in the denominator, and that's the only x value that would be bad. So there's our excluded values. So excluded values tell me what numbers are bad in a certain problem. And there you have it. That would be how you simplify a rational expression. All right, what about this? What about simplifying by factoring out a -1? So this is kind of a goofy thing in math that you see once in a while. And so we want to mention it here, and hopefully you'll be aware of it then whenever you think about it. Notice the top. We're going to simplify this. We're going to talk about when this is bad. Same thing we just did. But you might notice off the bat that you want to factor out maybe an x out of the top. Well, the first thing I hate is the fact that the x squared's not coming first. It's not in standard form, so I'm just going to rewrite it in standard form, and just to see if that does anything. Now, I don't like a negative in front of my x squareds because it makes it kind of hard to factor, but no big deal. So what I could do is I could just factor out a -1 if I want and be left with x squared minus 4x. Oh wait, they both have an x in them, so why didn't I factor that out? Well, let's go ahead and do that. So let's factor out a -x, and we would be left with x minus 4. Now what about the denominator? What two things multiply to -8 that add up to -2? Well, let me think. 8 and 1, no. 4 and 2. -4 and +2 would be winners of this. So our factors are x minus 4 and x plus 2. And look at there is a good point to decide whose excluded values. X should not equal 4 and x should not equal -2 because that would cause trouble. And we can still continue this because you may have noticed that something canceled. Awesome. And lo and behold, we are left with -x over x plus 2 as our final simplified value. And x cannot be 4 and x cannot be -2 because it would cause zeros in denominators. And there you have it. Why don't you try one, and I'll see you on the other side. Great work and a good job, and always worry about those excluded values when you do these problems. So now let's talk about multiplying. Multiplying's not too bad because multiplying's not very picky. Multiplying, in fact, look at that first part, that 3x to the 5th y to the y cubed. That's all multiplied together. The 3's multiplied to the x to the 5th, that's multiplied to the y to the cube. I could put them in any order, I could rearrange them, whatever. So when you multiply this 10 over here, it doesn't really matter, right? I'm going to multiply the 3 and the 10 together, or if I can, I'll reduce them or whatever. You can multiply these things together. And don't forget your rules of exponents. You got 5x's here, you got 3x's there, so there's going to be 8x's. But how we learn that is if they have the same base, we add their exponents. Now, kids will solve this thing two different ways, and I don't think it's bad either way. They will either multiply everything first and then reduce, or they will reduce and then they multiply. It doesn't matter. I'll do the multiplying maybe first and then reducing afterwards. So let me show you what that would look like. If I multiply, remember you're going to multiply all the tops together, so that would be 30 because 3 times 10, x to the 8th, y to the 7th, all over on the bottom. I would have 18 x to the 5th, y to the 7 plus 5, was that 12? And now I can reduce whatever I have. I see a 30 over an 18. Looks like they're both even, so I know 2 goes into it. They both add up to multiples of 3, so therefore 3 goes in, so 6 goes into both of them. So I think I would have a 5 over 3. Hey, I've had that before. Now look at the x's. You have x to the 8th and x to the 5th. That means there's 3 left over, and they'll be on the top because the top was bigger. So I see an x cubed on top, or if you would have subtracted, 8 minus 5 is 3, and that's positive, so it goes in the top. And then look at the y's, bigger numbers on the bottom, so it looks like we're going to have some y's left over in the bottom. In fact, we're going to have 5 y's left over, so y to the 5th in the denominator. And don't forget, if you subtract there, 7 minus 12 is -5, and -5 means put me in the denominator. And there you have it. Answer. Done. What expressions would be undefined? Well, I would have to say that x cannot equal 0 and y cannot equal 0 because they're both in the denominator. And there is your answer for 3A. All right, what about 3B? 3B or not 3B? Okay, sorry. Remember, the rules are we want to factor. If stuff can cancel, great. If it can't, no big deal. At least we factored. So the top, nothing to do there. The bottom looks like I can pull a 4 out and be left with x plus 5. Over here I have an x plus 5. And over here I have a difference of squares, x plus 3, x minus 3. That's the first time we've seen difference of squares come back. Make sure you understand your difference of squares because that shows up a ton. Now the good news is you can just multiply these all together. So you would have tops multiplied together and you would have bottoms multiplied together for x plus 5, x plus 3, x minus 3. And then you look to see if anybody reduces, and oh my gosh, x plus 5, right? They cancel. x minus 3, x minus 3, they cancel. And so the good news, my final answer, looks like nothing's left on top, so we better put a placeholder of 1. And on the bottom, I have a 4x plus 3. You could multiply that back together if you want. I choose not to, but I've seen people do it. I've seen them write 4x plus 12 because they think it looks prettier, and that's fine with me too. So there's your answers and what is not allowed. Now go back and look at all your fractions. Was there ever a time where something was bad? And yes, x cannot equal negative 5 from there. X cannot equal negative 3 from there. And x cannot equal 3 from there. So those are all my excluded values, and therefore I am completely done with example 3. All right, why don't you try one, and we'll get back to you after this. All right, some more beautiful work by yourself there. Good job. Now let's talk about dividing. Now dividing brings in my favorite thing, which is called copy.flip. Now, most of you call it copy, multiply, flip, or something. I don't know. You have fancy words for it. But all you have to do is remember back when you were little that if you had two fractions that were divided, that you would just copy the first one. So I'm going to copy the first one, change it to multiply, or what I call dot, and flip the second one, 8y to the 5th over 15. And now it's just like example 3 was. You can reduce now or multiply now. I don't care. Sometimes you'll see me do it both ways. Sometimes you'll see me multiply the top like I did in example 3. Here I'll show you one where I reduce first. I noticed that the 8s could cancel. I know that the 5 could go into the 15 3 times. So at this point you could now multiply tops and bottoms and then clean it up. Or you could keep going, like I see a y squared on the bottom and a y to the 5th on top, so that would leave a y cubed on the top. And I think this x squared would cancel this 4 out and just leave an x squared there. So now look what I have on top. I have x squared y cubed all over, what do I have on the bottom? 3? That's it? That's it. Done. Right? Now notice it said assume all expressions are defined. They're just saying that you don't want to worry about saying x does not equal 0, y does not equal 0. We're going to assume that there was no zeros in denominators, so we're golden. And there is our work for that. It could work just as well in B. In B, what you want to do is make sure you factor stuff out. So notice the top, I'm going to factor out an x squared and be left with x squared minus 9. Ooh, difference of squares, right? Also here, what is that? What two things multiply to 3 that add up to negative 4? I think that's x minus 3 and x minus 1. Now change it to dot. Flip, so x squared minus 16 will now be on the top, but I'm going to factor that to x plus 4, x minus 4, the difference of squares. And let's see, there I think I'm going to just pull out an x squared because it looks really confusing, but they all have an x squared in them. And I'd be left with x squared plus 2x minus 8. Now I got a little more factoring to do, like we said, that difference of squares right there. So x squared, x plus 3x minus 3 over x minus 3, x minus 1. Times over here, I got an x plus 4 and x minus 4. I have an x squared on the bottom. And what two things multiply to 8 that add up to 2? I think that's going to be 4 and 2, or negative 2. I should be careful. And there we go. Everything factored, right? And we don't have to worry about saying, you know, x can't be 3, x can't be 1, because they said assume everybody's defined. So now just start looking for things to reduce and cancel. And look, an x minus 3 canceling an x minus 3. An x plus 4 canceling an x plus 4. An x squared totally canceling out an x squared. And that looks like the end of the story. So it looks like my final answer, x plus 3 times x minus 4, all over x minus 1 over x minus 2. Now some people again will FOIL that out, and that's fine. I like to show it here that nothing else factored, so nothing cancels, I mean, and I could leave my answer like that. But if you do FOIL it out, great. No one would yell at you. And there's your final answer. All right, what about solving then? So solving is our last step and probably our trickiest step. We need to solve these equations. So as you see, I'm going to go ahead and solve this up. So the first thing I'm going to do is factor the top. So x plus 5, x minus 5 from the difference of squares right there, all over x minus 5 equals 14. Now notice at this point when you're solving, you want to be aware that you don't get a bad answer. So like x cannot equal 5. That's just to remind myself that if we get 5 as an answer, that was bad. Good news, x minus 5 cancel. Oh my gosh, that just made this really easy. X plus 5 equals 14. Subtract that over, and I get x equals 9, and there is my answer. Now check your solution, plug it in, right? 9 square it, you would get 81 minus 25 all over 9 minus 4, which, what is that? That's like 56 over 5. Why did I do 9 minus 4? Shouldn't that be 9 minus 5? I was kind of doing math in my head. And 9 minus 5 is 4. So I have 56 over 4, which reduces down to 14, which happens to be the right side. So that guy is good. Pat on the back. And move on to our last melon. Our last melon says this. Solve that bad boy. So notice right off the bat, I'm going to give myself a little warning here. X cannot equal 2. All right. Now factor your hearts out. Factor that top. What two numbers multiply to negative 10 that add up to 3? That would be x plus 5 and x minus 2. And then I have this over x minus 2. Sweet! The x minus 2's cancel, and we are left with x plus 5 equals 7. And that means x is 2. There's our answer. Oh, but what about that little warning we said in the beginning? Make sure you don't get 2, because that would put a 0 in a denominator. And so therefore this answer is extraneous. We have no other answers for this problem, so this has no solution today. And we cry a little bit because we thought we had one, but good thing we checked. And in fact, plug it back in and see. You could plug this in, your 2, and you could get 4 plus 6 minus 10 all over 2 minus 2 equals 7. And you will notice that 4 plus 6 is 10, and 10 minus 10 is 0. You get, what? 0 over 0? Well, 0 in denominator is always bad. That's why it's called undefined, because shouldn't that be 1? Should it be 0? Should it be undefined? We don't know, right? And that's why this is not a true statement, and there is no solution to this problem. That is all. Have a great day, and stay happy.